This video is on the objective use half-angle formulas to find values of trigonometric functions. This is number 2, the second video on a question from your homework related to this objective. Hopefully you've seen the first one as well, where I go through and actually developed all the half-angle formulas, and I'll refresh your memory here in a second what those are, what those look like. Let's take a look at the question though. So again, if you're unfamiliar with the topic, want to see more about it, please use the more instruction feature. Look at their videos, their notes, their examples, and hopefully those help you out. Alright, so here we're told some information about an angle called theta. The sine of theta is negative 7/25, and theta is an angle in quadrant 4. And as I think I mentioned in the first video, I'm going to assume that this is a positive angle. I'll use the smallest positive angle that ends in quadrant 4, because you'll see if you used a negative angle, it would give me a totally the opposite result when we go to choose whether or not we're using the positive square root or the negative square root. And then we're asked to find, if I know all this information about theta, what would be the cosine of half of theta? Alright, so before I get into actually doing the problem, let me refresh your memory as to what the half-angle formulas look like. So, and again, if you watched the first video, you saw me develop all these. The sine of half an angle, say half of alpha, is equal to either a positive square root or a negative square root, but it depends, right? That you choose one of these, you don't use both of them. And it all depends on what quadrant your half angle is in, right? What quadrant alpha over 2 is in. Then you have a square root of, and then this fraction 1 minus the cosine of alpha divided by 2. Right, and so whatever angle's inside this cosine here this is double the angle you're taking the sine of. Right, and then very similar for the cosine of half an angle, right, which is what we're going to be using in this video, this question. The cosine of half an angle is plus or minus, again, depending on what quadrant the half angle is in, right, this angle you're taking the cosine of. So you choose one of these depending on that quadrant. And then, again, big square root, and instead of 1 minus the cosine of alpha over 2 inside, you have 1 plus the cosine of alpha over 2 inside. And again, the angle inside this cosine here is double the angle you're taking the cosine of over here. All right, and then you had your tangent. Now the tangent of half an angle, again, you saw this hopefully in the first video when you were watching. There are 3 different versions that you could choose from and give you the same tangent of half an angle. One of them is this: the tangent of half an angle, half an alpha, is again plus or minus, you choose depending on what quadrant this angle you're taking the tangent of is in, right? Whatever quadrant half of alpha is in, that's showing that you'll use plus or minus depending on that. And then a big square root, and then the numerator here 1 minus cosine alpha divided by denominator 1 plus cosine alpha, all that inside the big square root. Now remember, I showed you last time you can manipulate this and get it to be a much cleaner looking version where the tangent of half of alpha is 1 minus cosine alpha in the numerator divided by sine alpha in the denominator, and no need to choose a plus or a minus here. No square roots, just very clean, very nice. Or manipulate this a little more. You could also say it's equal to sine alpha over 1 plus cosine alpha. Again, no plus or minuses, no square roots, much cleaner. And that's why I kind of put these in circles last time, put these in little bubbles, because I like them more than the one with the plus and minuses and the big square roots. Alright, but this particular problem, we're going to be finding the cosine of half an angle. All right, well, before we get to that half angle, we're given information about some angle called theta. All right. We're given this information about theta. We're told that the sine of theta is negative 7/25. Right. And that theta ends in quadrant 4. All right, so again, I'm going to assume that theta is a positive angle here. All right, I'm going to use a positive one, is what I mean. I'm going to use a positive angle. Because if you use a negative angle, you're going to end up with a different result, just the opposite result. So again, the plus or minus will come into play here, 1 plus, 1 minus. And let me draw a picture of this angle theta in standard position. So remember, angles in standard position, starting from the positive x-axis. And like I said, I'm gonna do the smallest positive angle theta that I can draw that ends in quadrant 4. Because you see, if I draw a small negative one, you cut that in half, you're still in quadrant 4. So it really depends on, I think they should have also just given us what the measure is, but I'm not the one who wrote this, so we'll just go based on what I'm trying to do here. So like I said, positive angle. So I'm going to make the smallest positive angle I can, right, going counterclockwise, that ends in quadrant 4 like this. So this is my theta. And the way I've drawn it, my theta here has a measure between 270 degrees and 360 degrees, right, because I'm in quadrant 4. So like I said, if you did a negative angle that ended here, cutting that in half, you'd still be in quadrant 4. Whereas when I cut this in half, it'll be in a different quadrant. So again, they really should have specified how they were drawing these, how they wanted you to draw them, what size, do they want a positive angle, negative angle, how big should it be, that kind of thing, instead of just saying it ends in quadrant 4. So like I said, I'm going to assume they're talking about the smallest positive angle that could end in quadrant 4. Alright. And then I'm going to pick a point on the terminal side like I do with every angle I draw. Alright, there's this point here. It has some x coordinate, some y coordinate. I want to find out what those are and draw a perpendicular segment to the x-axis, creating a right triangle with the reference angle for theta. Right, this angle here, I'll call it R. And I want to set up this right triangle so that the sine of the reference angle is positive, 7/25, because they gave me the sine. I want the sine of the reference angle to have the same value, just, it's going to be positive because reference angles are acute. All right. So remember, this is a sine, so opposite over hypotenuse. So the opposite length has a length of 7 units. And because this is down, I'm going to call this negative, pardon me, wow. I'm going to call this negative 7. So the y coordinate of this point here is negative 7. And the hypotenuse, 25, right? 25 for this hypotenuse length. And that's the value of r. Remember, r was that distance to the origin. And that was always a positive number in these pictures. So all I'm missing is the x-coordinate, this length here. And you can use the Pythagorean theorem, and I'm just going to tell you right now this will be 24 units. All right, 24 squared plus 7 squared is equal to 25 squared. But you could figure that out with the Pythagorean theorem as well. And that's I'm going to call that, positive 24 because it's to the right, and that means the x-coordinate of this point that I chose down here is positive 24. Alright, so now I have all the information I need for angle theta drawn. Let's figure out, they're asking us to find the cosine of half of theta. What if I took this angle I drew here? Again, the angle I specified was between 270 degrees and 360 degrees. Or, 3 pi over 2 radians and 2 pi radians if you're doing radians. What if I were to cut this angle in half? What would be the cosine of that new angle? Right, so we're looking at a new angle, half of theta. Now, it would be nice to know, again, based on this drawing, like I said, if you used a negative angle, it would be totally different. But based on this drawing, theta is between 270 degrees and 360 degrees. Cut that in half. Now, if I cut that in half, right, that would just cut everything in the inequality in half. And theta over 2 would be between 135 degrees and 180 degrees. Now, if you're between 135 degrees and 180 degrees, that means you're in quadrant 2, aren't you? Because 135 degrees and 180 degrees, you're over here somewhere, right, if you're drawing in standard position going in the positive direction. So, keeping that in mind, and using my formula for the cosine of half of theta, right, the cosine of this theta divided by 2. Remember, the first part was to choose, am I going to do the plus or minus? Is it going to be the positive square root or negative square root? Well, if I'm in quadrant 2, right, this half of theta I just showed you, based on my previous drawing, would be in quadrant 2. And if you're in quadrant 2, remember the cosine of an angle in quadrant 2 is negative. Right. That's why I'm going to use the minus sign here. So negative square root, and then the formula was, this big square root of 1 plus the cosine of theta, right, all divided by 2, inside this square root. Alright, so in order to find this value out, I need to know the cosine of theta. Well, back on my picture of theta, we were told the sine of theta, right, was negative 7/25, and I can very easily from this picture tell you what the cosine of theta was. It would be 24/25, positive 24/25. So that's what I'm going to plug in to my formula here. Alright. So now, plugging that in, we get, the cosine of half of theta, again, based on the way I drew theta earlier. Half of theta would be in quadrant 2, so the cosine would be negative. Then we get this square root of 1 plus the cosine of theta, which, again, I just showed you was positive 24/25. And then all of this divided by 2. And again, a crazy complex fraction here. I want to get rid of this 25, so I'm going to multiply that at the top here by 25 and the bottom by 25. Right? Now there are 2 terms up top, so I need to distribute the 25. And that gives me the following. We have negative square root. Now the 25 times 1 is 25. Plus, and then 25 times 24/25, the 25s would cancel, and I got 24 divided by, and then 2 times 25 is 50, and I'm getting negative square root of 49/50, which is perfectly fine. You could enter that. I'm going to go through and rationalize it, though. Now, the square root of 49 is just 7. Right, so the numerator is just 7. The square root of 50 is the square root of 2 times the square root of 25. So that's 5 times the square root of 2. And then if you multiply the top and bottom by square root of 2, you get negative 7 times the square root of 2 in the numerator, and then 5 times 2 in the denominator, 10 in the denominator. Right? So this, if my drawing is correct, right, we have if the angle they're talking about was positive, which again they should have mentioned. I wish they had written it differently. I'll send some feedback to Newton. But if it was positive, if it was something between 270 and 360, half of it would be between 135 and 180, so the cosine would be negative, and the cosine of that half angle would be this negative, 7 times the square root of 2 over 10. And that's what I'm going to enter. All right, so back here, so I'm going to put in, negative 7 times the square root of 2, and then all of that divided by, and make sure it's, the 10 is not in the square root. All right, wonderful. So they must have used a positive angle, because again, if you used a small negative angle, half of that would have still been in quadrant 4, and your cosine would still be positive. So they must have used a positive angle. Again, I wish they had said that. All right, so I'm going to type in some feedback here, and that'll be that. All right. So hopefully, watching me go through this. And I guess my best thing to you would be just assume a positive angle when we're talking these problems. Hopefully watching me do this here, looking at more instruction, help you when you're asked to go through and do these problems on your own. And thank you very much for watching.